Welcome back. So now we want to look at these equations that negative x squared divided by 4 minus y squared plus z squared divided by 9 is equal to 1. Now this is a quadratic surface again, and the general equation looks like this, where you get z squared over c squared minus x squared over a squared minus y squared over b squared is equal to 1. Anytime you have an equation of this form, the graph would be a hyperboloid of two sheets, and we'll see how that looks like. So first of all, for this example here, let's look at the yz trace again. So the yz trace, to find that, I have to plug in 0 for x. If I do that, I get z squared over 9 minus y squared is equal to 1, which we know to be a hyperbola. Remember that a hyperbola has two parts that look like, each part looks like a parabola, and the vertices are at the points plus and minus plus 3 and at minus 3 on the z-axis. So this is the yz trace. Now we're going to look at the traces in the planes z is equal to k. Now these are the planes parallel to the xy plane. So what's the trace there? Well, if z is k, I can plug in k here, and if I do that, then notice that, so what I'm going to do is plug in this equation. I'm going to send these two terms on the right, and I'm going to send one to the left. So if I do that, I get this. Now, so here I can see that because the right hand side is non-negative, so is the left hand side. So the left hand side is non-negative. That tells you that z squared minus 9 is non-negative, and as a result z squared is greater than 9. Now if z squared is greater than 9, then either z is greater than 3 or z is less than negative 3. Now obviously if z is between negative 3 and 3, then z squared would be smaller than 9. So we see that z squared greater than 9 tells you that, okay, sorry, I should be writing z here. I should be writing z here. Z is greater than 3 or z is greater than negative 3. Z is less than negative 3. Now, why did I do that? Well, because we're looking at the traces in z equals to k, but the trace would be empty when k is between negative 3 and 3. So we get a trace in these planes when k is above 3 or k is below negative 3. So what's the trace in z is equal to k? Well, the trace would be, we plug in k for z, and then if we do that, so in this equation, I'm going to plug in k here, and then I'm going to move, well, basically this is, remember, this equation is the same as that, so I'm going to plug in k here, and then what I'm going to get is k squared over 9 minus 1, and then this expression here on the left. Now this is the equation of an ellipse. This is a constant here. It's a positive constant. So this would be the equation of an ellipse. So we see that traces parallel to the xy plane are all ellipses. So if we put together the yz trace here, and then the traces in planes z is equal to k, we get these ellipses. So we see the shape of the surface now, and this is called the hyperboloid of two sheets for obvious reasons, because there are two parts here. Okay. If we were to look at the xz trace, the xz trace will also be a hyperbola. Okay, so that's So that's a hyperboloid, a hyperboloid of two sheets. Now, what if I make a little change here? So that is, let's say I make this negative sign a positive, and then I put a negative sign in front of the z term. So what's going to happen? Well, the only thing that's going to happen is that you see the hyperboloid of two sheets here, the two points here and here, the vertices here, they will be on the y-axis, so they will extend along the y-axis if I make this slight change here. That is, if I make this plus and if I make this negative, that's what's going to happen. Okay, so that's the end of hyperboloid of two sheets. In the next one, we will be looking at cones.